Hey, this is Jake Bartlett for School of Motion, and I am going to be teaching you how to make a tapered stroke rig in After Effects using expressions. Now, expressions are a very intimidating topic, let's face it. Code is just not a language that most motion designers speak. But if you can understand some very basic principles of how to use expressions as a problem-solving tool, the possibilities that they open up are pretty incredible. You can create entire setups inside of After Effects that allow you to do things that natively After Effects can't even do. They're an extremely powerful tool to have in your toolbox, and hopefully after this lesson you will have a very good grasp on how to use them to your advantage. So let me start with my big fat disclaimer up front. We are going to be writing a lot of code in this lesson, and it's going to get pretty geeky, but it's not going to get too complex. Really, we're going to be more clever with our expressions, so you should have no problem following along. I'll go step by step, and at the end we'll have a tapered stroke rig that you can reuse over and over in any project. Alright, let's get straight to it. I'm going to make a new composition, and frame rate doesn't really matter. Resolution, I'll do 1920 by 1080, and I'll set the background color to white just so it's easy to see. And I'm going to start by drawing a line. Now, natively, shape layers do not allow you to taper a stroke in After Effects. It's a single width all the way along your line. There's no control for that. The only real solution that I know of that exists is Trapcode's 3D stroke, and the reason I don't really want to use that is because 1, it's not free, and 2, it works with mask paths, so I don't have all of the controls and special operators that shape layers allow me to have. So when I approached this problem originally, my goal was to have a line behave exactly the same way that I'm used to on a shape layer that I could control with trim paths and use all kind of operators on, exactly the way that I was used to, with the additional control of being able to control the width of the line from one end to the other. So let me show you what my original concept for that even being a possibility was. I will go into my contents and add a trim paths on the shape group. I don't need that fill. And I'll make my stroke round caps and round joins. Then I'll take my trim paths and set the end value to 10. And I'm going to make a bunch of duplicates of this group. So let's say 10. And then I will bring up all of the start and end values. And I want to offset each one of these by 10% so that I have 10 different segments. So I'm just going to do that really quick. Not a very fun process to have to do this. All right, there we go. So we've got 10 segments, all offset by 10% on the trim paths. Then I will open up the stroke width and offset each one of these by 10 pixels. So 100, then 90, all the way down the line. All right, there we go. So if you take a look at this line, it's totally crude, but you can kind of see the concept working. Basically, if you segment this line and offset the trim paths of each one of them, as well as the stroke width, you kind of get a taper. Now, obviously, you would need a lot more segments to make this not noticeable. And doing it by hand is pretty much out of the question. That takes way too much time. And I have all of these duplicate groups that each have a copy of the same path. So if I were to go in and try and modify this path, that's only controlling this segment. Then I've got another path. Another path. Really, I would want one path to control all of the segments. So I wanted to figure out a way to get expressions to do all this complicated work for me so I didn't even have to think about it, and I'd be left with a tapered stroke. So now I'm going to walk you through how I used expressions to solve that problem. I'll start by deleting all of the duplicate groups, and I will rename this master group. Then I'll duplicate that group and rename it taper01. And I'll regroup that group and name it duplicate groups. Now, setting up this structure is pretty important because we're going to be referencing a lot of different properties and groups within this layer structure. So naming is super important. So let's continue this structure and rename the contents of the master group master path, master trim paths, and master stroke. All right. In the duplicate groups, I will go into the taper01, and that is all just fine the way it is. So I want these expressions to be based off of the master group. I want all the duplicates to be following the master group, and then the expressions that we use will automatically divide this line up into segments and offset the stroke incrementally. So the first thing I want to do is link the duplicate path to the master path. So this is what we're going to use our first expression for. If you've never used expressions before, you just go to any property that has a stopwatch for the keyframes and hold down Option or Alt on a PC and click on that stopwatch. That will open up the expression dialog box and give us a few extra controls, and it automatically fills in the code that references the property that you were putting that expression on. Now, I don't need this line of code. I actually need the code that references the master path. But I don't actually have to know how to type that out or what the code to reference that is. There's this little expression pickwhip that behaves just like the parenting pickwhip. I can click and drag it and then come down to the master path and let go. And then After Effects will automatically fill in that code for me so I don't have to do any coding. It's as simple as that. I just click off to apply it, and now that duplicate path follows the master path. And if I offset the trim paths for this group, just so we can see the two different groups, grabbing this path and moving it around, you see that it looks like there's only one copy of that path because this path will always follow it now that we have that expression. So awesome, we're already using expressions to make stuff work. Let's keep going. Next, I want to add some expression controls. So I'm going to come up to Effect and go to Expression Controls, and you'll see this whole list of controls that we can add. Now, on their own, expression controls do absolutely nothing. They're basically there just to give you values that you can use to control expressions. So the first one we'll start with is slider control. So go to Expression Controls, Slider Control, and by default, a slider, if I twirl this open, has a range of 0 to 100. You can grab this number and go past that range in either direction, and you can also right-click on the slider and say Edit Value to adjust that range. We're not going to need to do that, but just so you're aware, if you ever need to have a different range of numbers. 0 to 100 is going to work just fine for what we're using it for, though. So I'm going to rename this slider Stroke Width, and then I want to link the master stroke width to that slider. To do that, I'll just hit Option and click on that stopwatch to add the expression. Grab this expression pickwhip, and I can actually come up to the Effects Controls panel and let go. And there we go. The After Effects fills in that line of code for me. I click off of it, and that number turns red. Now, that means that there's an expression driving this value. I can click and drag on this number, and you see it's changing, but as soon as I let go, it switches back to 0. The reason why it's 0 is because our stroke width slider is set to 0. If I adjust this, you see that now the stroke width of my master path is being controlled by that. And just like I said before, I can increase that to a higher number if I need to, but I seriously doubt I'll ever need a stroke width higher than 100. So I'm going to leave the range right where it is. Next, I'm going to duplicate this slider, and I'll rename it End. And I want to tie the master trim path's end value to that slider. So I will add an expression again and pick whip that slider and click off. Now if I move this slider around, it controls the end value. And because the end value is a percentage of 0 to 100, the range of 0 to 100 is perfect for that value. So no need to change that. Next, we need to add another type of expression control. I'll come down to Angle Control, and this is going to be a value measured in degrees. So the offset control is measured in degrees as well. So that's the type of controller I want to use to drive that property. So I will add my expression, grab the pick whip, select the angle control, and click off. Now that angle is controlling the offset of the trim paths. Now if you take a look at the way that After Effects wrote this expression, it's referencing the effect angle control and the value of angle. But the important part that I want to point out is that the name of this effect is angle control, which you can see up here. If I change the name of this angle to offset, the expression just updated based on what I named it. So After Effects is pretty intelligent in that sense, which is a really nice feature. All right, so we've already got 3 controls driving our rig, but there's a lot more you can do with expressions than just linking properties to expression controllers or to other properties. You can have complex equations, you can base stuff on time, offset keyframes. There's all kinds of possibilities. Again, we're not going to get too complex, but we are going to start writing some code of our own. So this is where I want to introduce an extension for After Effects called Expressionist. So I'm going to switch over to my Expressionist layout and make this window bigger over here. Now, Expressionist is an expression editor that is much easier to work with than the expression editor built into After Effects. As you can see down here, I'm confined to this window. I can't change the size of the font, and it can get pretty complex if you have a lot of lines of code with not a lot of room to work with. Expressionist behaves a lot more like an actual coding program inside of After Effects, and it has a ton of great features. If you're serious about learning how to write expressions and making your own things with expressions, I highly recommend that you purchase Expressionist. It is totally worth the money, and we have a link for it on this page so you can go check it out. If you think you're going to get it, I would even recommend that you pause the video, go buy it, install it, and then come back so you can follow along with me inside of Expressionist. It's fine if you don't use Expressionist. Everything I do in here is completely doable inside of After Effects. Expressionist just makes it a lot more easy to look at. All right, so the first thing I want to do is work on the start value of the master trim paths. So I'm just going to clean up my layer a little bit so I can just focus on what's important. I want the start value to be based on the end value and the total number of groups in my layer. So the number of duplicates that we have in this group here. Right now there are 2 groups total, the master group and Taper.01. So I want the start value to be the end value divided by the number of groups, which is 2. So it should be 50. So what does the expression look like that would get that to happen? Well, let's write that code. I'll come over to Expressionist, and I will select the end value, and down here I have this pick whip. I will click it once, and Expressionist fills in the code exactly the same way as if I was writing the expression down here and using the expression pick whip. Now, the syntax that Expressionist uses is slightly different than the syntax After Effects uses. And syntax is just the structure and the naming conventions that coding languages use. So things like putting names in quotes and putting groups in parentheses. The thing is, After Effects natively uses one naming convention for its syntax, and Expressionist just uses another one that's a little bit more consistent. Expressions are based on the JavaScript language, and it's pretty flexible in the way that you can write things. If you look down here, After Effects puts content, master group, dot content, master trim paths, and Expressionist uses parentheses and double quotes for each one of those groups instead. So you see contents, instead of being separated by periods, is just in the exact same format as the other groups. The end result is exactly the same, it's just a little bit different way of writing the code. So if you're not using Expressionist, just know that anytime I click on the pick whip, my code's probably going to look different than yours, but the end result is going to be exactly the same, so don't worry about it. All right, so that code references the end value, and then again, there are 2 total groups, the master group and the Taper.01. So I want to take this end value and divide it by 2. Then I'll apply that to the start value by having my start value selected and then inside of Expressionist pressing Command Enter. That applies the expression, and look at that, our start value is now 50% because it is 100, the end value, divided by 2. So that's great. If I go into my effects control and I adjust this slider, you see that the start value of the master group is moving in proportion to the end value. So if this was set to 50, then the start value is 25% because it is half of the end value. Great. The problem is that hard-coded number is not going to update with the number of groups. So if I were to duplicate these groups, this value doesn't change at all. So instead of using a 2, we need to tell After Effects how to count the number of groups and automatically fill that in instead of a hard-coded number. So I'll delete these duplicate groups, and now I'm going to show you really quickly how to get a group's index. So I'm just going to make a new composition really quick for a demo. You don't have to follow along with this. I'm going to make a new solid, and you probably already know that this number over here in this column is the index value of the layer. That's what After Effects calls its number. It's an index value. What you might not know is that inside any layer, every group, every effect, and every property has an index value. There's just no number next to it. So inside of this layer is a transform group. Right now that's an index value of 1. If I add, say, a fast blur to that layer, now there's an effects group. So in this hierarchy, the index value of effects is 1 and transform is 2. If I open up the effects and I duplicate this fast blur 5 times, now there's a hierarchy inside of the effects group. Fast blur 1, 2, 3, 4, 5. So I'll open up the 5th fast blur and I'll add an expression on the blur value. And I'm just going to type in a simple expression, this property, so the property I'm writing the expression on, dot property group parentheses 1, close parentheses, dot property index. I'll apply that, and now we have a value of 5. So this expression is saying this property, the blurriness, property group 1, which means the property group 1 level higher than this property, give me the property index for that value. So 1 level higher is fast blur 5 from the value that I'm writing the expression on. If I change the order of this fast blur to the 3rd position, that value updates to 3. And if I copy this expression to all of the fast blurs and double tap the E to bring up all the expressions, you see that the index value is reflected in the fast blur's blurriness, and it updates based on the order of the effects. So that's how we can find the property index of any value. So I'll go back to this main comp, and things get a little bit more tricky when it comes to shape layers. To show you what I mean, I'm just going to go into the stroke of this Taper01, and I'll add an expression onto the stroke width. So if I type that same expression, this property dot property group 1 dot property index, and I capitalize this property. That is not the proper syntax, so that would have broken the expression. So that is something that is very important to take note of. It's very common for commands and expressions to start with lowercase, but then the second word of the command to be uppercase, and every word after that uppercase as well. And if you don't follow that syntax, the expression will break. So anyway, we've got this property, property group 1, property index. So the index of stroke 1. So it says it's got a value of 3. If I move it up, it goes to 2. So we know it's working. Here's where it gets interesting. The next level up is Taper01. So you would think if I change this to group 2, we should get the index value of Taper01. But this is returning a value of 2, and there's only one group inside of duplicate groups. If I duplicate this taper, the value doesn't change. I can do it as many times as I want. It's always going to be 2. So the reason this is happening is because there's actually an invisible layer of the hierarchy that we're not seeing. To show you what I mean, I will grab the stroke width, and let's get rid of this. I'll clear it out, and I'm going to pick whip that stroke width. So let's look at this layer structure that it gave us. Starting at this layer, contents, duplicate groups, contents, which we don't see, Taper01, contents again, then stroke 1, then stroke width. So the reason this is happening is because there is an invisible layer of contents inside every shape group. It's a unique thing to shape layers, but it's very important to be aware of because when we're using this property group command, we need to account for those levels of the hierarchy even though we can't see them. All right, so let's get rid of that expression and we can actually start doing some coding. So let's go back to the start value. I will load that back in, and I'm going to get rid of this divided by 2. Now obviously this line of code is not that easy to look at. It's pretty long, and it would take you a little bit to figure out what exactly it's saying. It's not very clear. But expressions allow you to create what are called variables. And a variable is basically a way for you to create your own shorthand so that your code is easier to look at. So I'm actually going to clear out this entire line of code, and I'm going to start over by writing a new variable. So to write a variable, you start by typing var for variable, and then you need to give it a name. So I'm going to name this end, and then an equal sign, and then the line of code that you want end to contain. So I want to go to the effects and to the end slider, and expressionist can't pick whip anything from the effects control, so that's why I went down to the effect. But then with that selected, I will click on the pick whip and end that variable with a semicolon. It's very important that you end it with a semicolon, or else After Effects will not know when that variable is supposed to end. But there you go. Now I can use end in anywhere in my expression after that line, and it will automatically interpret it as this line of code. Cool. So the next variable that I need is the total groups. So I'll make another variable and name it total groups. And then I need to write the expression that will give me the total groups. So I'm going to pick any property within this Taper01. So we'll just say the opacity, pick whip it, and then I can get rid of everything on this line of code that I don't need. Remember, I want to count the number of groups within duplicate groups. So I need to go to this layer, contents, duplicate group, contents, that invisible layer of contents, and I can get rid of everything else. Then I'll type in a new expression. It's very simple, .num properties. And what that's saying is take the number of properties that are within the contents of that group. So now I can write my equation. So I'll drop down 2 lines and I'll say end divided by total groups. And I'll end that with a semicolon. Now, After Effects is pretty forgiving and will generally still carry out a command even if you don't end the line with a semicolon, but it's just a good practice to get into to make sure that there are no mistakes in your code and no errors pop up. So just get into the habit of ending every line with a semicolon. All right, now that I've got that written, I will apply it to the start value. And the value goes to 90.7, which is exactly the end value. So let me just make this 100% to make it more clear. Why is the end value, 100, divided by the total groups, also 100? There are 2 different groups, so it should be 50, right? Well, the problem is we defined total groups to be the number of properties within duplicate groups, and the master group is not contained within that. So the expression is actually working exactly the way it's supposed to, it's just not what we want. So we need to account for this master group within our variable for the total groups. And it's very simple to do that. All I have to do is add a +1 after num properties. And that will automatically increase the number of properties by 1 anytime it references it. So let me reapply that to the start. And there we go. We're back to 50%. And now if I duplicate this group, you see that the end value updates as well. Now, it's not updating the way that I need it to, but it is being based on that total number of groups, which is progress. So we're doing great. Let's delete those duplicate groups, and then we need to add another factor into this, which is the segment length. So I actually need to duplicate my end slider, and I'll rename it segment length. And I need to define a variable for that slider. So I will drop down here and type in var seg length, just for short, and then open up the segment length, pick whip it, and finish off that variable. Now I want to update my equation to be end minus the segment length divided by the total of groups. And if you remember back to your algebra days, the order of operations applies here. And by that, I just mean multiplication and division is going to happen before addition and subtraction. So this equation is going to play out like this. It's going to take the segment length, 100, divided by the total groups, 2. So that becomes 50. Then it's going to take the end value, which is 100, and subtract 50 from it. And it'll do it in that order. So let's apply that to our start value. And now when I duplicate this group, you see this number is getting bigger, closer to 100, making the segment length smaller with every duplicate. That's working exactly the way it needs to. And that's actually all we have to do for the start value. Now we can move on to the duplicate groups. All right, hopefully you're following along with no problems. I know this is a lot to take in, but hang in there, we're making really great progress. Let's get into the trim paths of the Taper01 and start with the end value. Now really, I want the end value of the first duplicate to be in the exact same place as the start value of the master trim paths. Or another way to think about it is I want the end value to be the same as the master end minus one segment length. Now that might sound a little bit confusing, so instead of talking about it, I'm just going to show you. Let's write the expression for the end value. I'll load that up into Expressionist by shift-clicking into the editor. And let's define some variables. So var end equals, and we'll grab that end slider. Then we'll add a variable for the group index. And I'll write the same expression we used before. This property dot property group 3 dot property index. And the reason I chose 3 is because 1 level up is the trim paths, 2 levels up is that invisible layer of contents, and then 3 levels up is Tapered.1, which is the index value that I need. So this property group 3, property index. Then I'm going to define one more variable, and I'll put this on the second line. And I'll name this master start. And this is going to be the master trim paths start value. And then one last variable for the segment length. Now this segment length is going to be different than the actual master paths segment length. I don't want it to be based exactly on this slider. Instead, I want it to be based on the trimmed portion of the master path, so whatever the length that segment is. To find that, all I have to do is subtract the start value of the master path from the end value, which is the same as the end value of the slider, which is why I pick-whipped the end slider instead of the master end. So for the segment length, very simply, I just want to write end minus master start. So within this variable, I'm already referencing variables that I've defined up here. That's an extremely powerful feature of variables. As long as the variable was defined before this line, I can already use it. All right, so now that all my variables are defined, I'll actually write the equation. I want this end value to be the end value minus the segment length times the group index. So let me walk you through this. The end value, master end set here, minus the segment length times the group index. And again, order of operations, it's going to do that multiplication before this subtraction. The segment length is this segment, the master paths segment length, times the group index. In this case, it's 1, so end minus 1 segment length. Let's apply that to the end value, and it's set to 50. Which is exactly the same as the start value of the master trim paths. I'll set this Tapered.1 to multiply just so you can see this is perfectly overlapping, so there's no gap between the two lines. And if I adjust the segment length, you see that that updates with it, and the end value also controls that. So what happens if I duplicate this group? Well, it offsets, and this is segmented evenly. I can duplicate this a bunch, and you see that all of these end values are spread out evenly, and the segment length proportionately spaces everything out. So I hope you're getting excited. This is actually working. Let's delete the tapered groups. And now we need to do the same thing for the start value. And the variables can actually stay the same, so I'm just going to reuse this instance of Expressionist. The equation just needs to change slightly. Instead of the start value being based on the end value of the master trim paths, it needs to be based on the start value. So instead of end, I'm going to type in master start. And I'll apply that to the start value. Everything else is the same. Now when I adjust the segment length, look at that. The end value of the duplicate and the start value of the master stays directly in the center there, and everything else gets spaced out proportionately. I can duplicate this a whole bunch, and just like that, everything is perfectly spaced out, and I'm able to adjust the length of that line and animate it exactly the way that you would expect a shape layer to behave. If I move the offset angle, now there's something I forgot to do. I did not set up the offset of any of the duplicates to be based on that, but that is an easy fix. I'll just delete all of my duplicates, option click on that offset, expression pick whip the offset value. Now that's all linked up, I'll reduplicate this a bunch of times, and now I can use that offset control exactly as you would expect it to be used. So that's really awesome. We've already solved the first part of the problem. which was automatically dividing up that segment based on the number of groups. Now, obviously, if I take off this multiply, this line looks exactly the same as it did when we started. So we need to solve the other half of the problem now, which is offsetting the stroke width. So take a deep breath, and let's keep going. I'm going to delete all of these duplicates again. I'll set this back to multiply just so we can see where the two lines are segmented. And I'll collapse the trim paths for both groups. And I will open up the stroke 1. This is where we're going to be working. And before I forget, I'm actually going to link some of these properties up. I want the color of all the duplicates to be driven by the color of the master stroke. So I will directly link that. I don't think I'll need to mess with the opacity, so I'm going to leave that the way it is. But let's start writing the stroke width expression. So I will select that and then shift-click into Expressionist to load that property up. And we'll start by defining more variables. So let's start with the stroke width and pick whip the stroke width slider. Then we're going to need to know the group index, which we can actually pull from the trim paths. That variable is going to be exactly the same. Let me find that. Group index. Copy and paste that in. And we're also going to need to know the total groups. So I'll define that variable, total groups equals, and I'll just pick whip the stroke width. And again, delete everything I don't need. So I need to know the duplicate group's contents, the number of properties in there. So I'll delete everything after that and type .num properties. And there's my total groups. So let's write the equation. I want the stroke width to be based on the slider's stroke width. So I'll type in stroke width divided by the total groups times the group index. So let's apply that expression to the stroke width. And it stays at 100. Now, again, that is because we did not account for the master group in our total group. So I need to come back up to that variable, add +1 at the end, then update that expression, and now it is half the width. Let's duplicate this group a bunch of times, and it seems to be working kind of. It's not doing exactly what I expected. This taper is going in reverse, and the master group is on the wrong end. So the reason why this is happening is because even though this counts taper 01 all the way up to taper 10, the index of structure starts at the top and goes down. So every new duplicate is actually the index value of 1. So taper 10 is now 1, 9 is 2, all the way down the line. Taper 1, which is here at the end, has the group index of 10. So what I need After Effects to do is reverse that index order. And it's actually pretty simple. All I have to do is type in total groups minus the group index. And I need this to be calculated before it's multiplied by the rest of the equation. So to make that happen, I just have to put this within parentheses. So what's happening here is going to take the total number of groups. So right now there are 10, actually 11 because of the extra, and then subtract the group index from it. So if taper 01 it has an index value of 10, I'm going to take the total number of groups 11 and subtract 10 from it, and it's going to become group 1. And say group 7, we'll take the total groups again, 11 minus 7 is 4. So that's essentially reversing my index order. So I'll delete all these duplicates, go to my stroke width, and then reapply this expression. Now if I make some duplicates, look at that. Our stroke is tapering in the correct order. And if I have enough of these, I'll turn off the multiply. That segmentation gets less and less noticeable. Now, this is great, except that I have no way to control how thick or thin this taper is. So we need to add one more piece of the equation into our expression. And I'll start by adding a new slider. I'll just duplicate the end and rename this taper out. Then I'll delete all these duplicate groups. And this last part of the equation is a function within expressions called linear interpolation. And that sounds complicated, but once you understand it, it is an incredibly powerful tool. So again, I'm going to jump into a new composition. You don't have to follow along with this. It's just for a demo, but feel free if you want to. I'm going to make a square again, and I'm going to add a slider control to it. And this slider by default goes from 0 to 100. Now, let's say I wanted to change the rotation of this layer. So I'll bring that up. And rotation is measured in a value of degrees, while the slider control is just a hard number. If I wanted this slider to control the rotation of this square, where 0 was 0 degrees, but 100 was one entire rotation, that wouldn't work if I directly linked them together. And I'll show you. If I just link this to the slider's set to 100, the angle of the rotation goes to 100. It doesn't go to 1 revolution because 1 revolution is actually a value of 360 degrees. Now, linear interpolation allows me to remap any range of values to another range of values. And I'll show you what I mean by that. Let's load this expression up, and I'll define this as a variable. So var slider equals, and then this code for the expression, end it with a semicolon. And I'll come down and say linear, parentheses, and then I need to tell the linear expression what values to look at. So I'm going to type slider. So I target the slider control, and then I need 4 numbers. So I'm just going to put a comma, 0, 0, 0, 0. So we have 4 numbers. This is completely arbitrary right now, but I'll tell you what these mean. The first number is the input minimum value, and the second number is the input maximum value. So the range of numbers of that slider that we want to pay attention to. So I want the range to go from 0 to 100. So 0 is fine, and the second number will be 100. The second set of numbers is the output range. So the minimum output and the maximum output. So when the slider is set to 0, which is the input, I want to interpret that number as this number, the output. So 0 is actually fine. When the slider is at 0, it should be at 0 degrees. But when the output slider is at 100, I want the rotation to be 360 degrees. So I'll type 360 degrees there. And then I'll finish this off with the semicolon. And just one more time, I'm going to run through this again just so it's crystal clear. We're targeting the slider values and taking the range of 0 to 100 and remapping that range from 0 to 360. Let's apply that expression to the rotation. And now this is set to 100, and you see that we have 1 full revolution. And if I adjust this slider, you see that it makes an entire rotation from 0 to 100. So that's an example of what linear interpolation can do. Now you can do a lot more than hard-coded numbers in the linear interpolation. You can use variables, you can do equations, and you don't even have to use a full range of numbers. I could have said from a minimum input of 25 to, say, 75. And then if I reapply that to the rotation, now until this value reaches 25, nothing happens. But you see that as soon as it hits 25, it starts rotating. And then once it gets to 75 is when that rotation finishes its entire revolution. And then from 75 to 100, nothing happens. So it's an extremely powerful function, and it's a key factor in getting our tapered stroke to work the way that we want it to. So let's go back out to our tapered stroke, and you can jump back into following along. I'll load up the stroke width again, and now that we have this taper out slider, let's put that into our variable list. So var, and we'll call it taper out equals pick whip the taper out, semicolon. And then I'm actually going to take this equation and make it a variable. So I'm going to type var and name this stroke taper, equals, and then this equation. So now anytime I type out stroke taper, it's just going to interpret that as this entire equation. Now, our new equation is going to be a linear expression. So we start by typing, whoops, I had my layer selected. Let's get back to the stroke width. All right, there we go. So linear, parentheses, and I want to look at the taper out slider. So taper out, comma, 0 to 100, comma, stroke width, comma, stroke taper, and then end it with a semicolon. Now, what does this expression say? It's saying take the range of 0 to 100, and in this case, I'm treating this kind of like a percentage. When the taper out is set to 0%, I want no taper, and when it's at 100%, I want the maximum taper. So the range of 0 to 100% is remapped to the stroke width, which makes sense because when there's no taper, the duplicate groups should match the stroke width of the master. And when it's at 100%, I want it to be the stroke taper, which is our equation that makes the taper work. Anything in between is automatically interpolated between those two values. So this is making the expression extremely flexible, allowing us to control things with variables instead of fixed hard-coded numbers. Let's apply this to the stroke width and duplicate the group a bunch. So now we have 10 total groups. And now watch what happens when I adjust this taper out slider. I hope I just blew your mind because that is a working tapered stroke with full control of the taper. And if I duplicate this group a whole bunch and maybe lower the stroke width to say 50, it's starting to become really difficult to see that there are any segments in there. And I can go ahead and modify this path to say be a curve like this, and then maybe change the segment length so it doesn't take up the entire line. And this is a completely working tapered stroke. If I set some keyframes, let's zoom in here. Just something really simple. We'll go from 0 to 100 on the end value. And then I will just ease these keyframes really quickly. And let's RAM preview. This layer animates exactly the same way that a single path would on a shape layer, but we have these added controls of being able to taper the stroke, control the segment length, and the stroke width, all right here, with lots of calculations taking place behind the scenes so that we don't even have to think about it. All we're left with are the animation controls that we're already used to using. And if I closed this path and maybe made this like a figure 8, then instead of animating the end value, I could animate the offset. And I'll just put it at 1. And then I will RAM preview that. And we now have a looping tapered stroke going around this figure 8. So it's time to place your head between your knees, take some deep breaths. We just built a freaking tapered stroke rig inside of After Effects on a single shape layer using expressions. That is pretty incredible. Now, the way that I like to animate with this is usually with a low number of groups, usually around 10. And then once I'm ready to render, I'll really crank up the duplicates. Now, if I go ahead and do that, say there's 40 groups, you might notice that After Effects is starting to slow down a little bit as I'm working with this. And it's just because with every group duplicate, After Effects has to recalculate all of these expressions that we wrote for every frame. So typically, like I said, I'll work with, say, 10 groups, and that's generally quick enough. And then once I'm ready to render, I'll just increase the duplicate count until that taper is no longer noticeable, and then you're ready to roll. Holy crap, that was a lot to take in. We just covered linking properties directly with expressions, defining variables, writing equations, determining index values of groups, and counting the number of groups within a group, and linear interpolation. I know that that was a lot to take in, and if you're anything like me, you're probably pretty overwhelmed right now. But if you were able to follow along and you can grasp all the concepts that I covered, you are well onto your way to harnessing the power of expressions to allow you to build things, to make animation the priority, and make really complex, intricate processes happen in the background so you don't have to think about it. Now, we can actually build a lot more functionality into this rig, but we're going to save that for the next lesson. For now, give yourself a hand, pat yourself on the back. That was an incredible amount of coding, especially if you're new to expressions. Now, if you got lost at any point and you really don't feel like going back and figuring out what went wrong, you can always sign up to be a VIP member of School of Motion and download my project file for free. Then you can just use my project and take that tapered stroke rig that I just built and reuse it in any of your own projects. And again, I can't say enough good things about Expressionist. We didn't even cover all of the amazing features that it allows, but I'm sure you noticed that seeing this color-coded syntax makes looking at these expressions much easier than working in these tiny little boxes with no highlighting at all. It'd be much more difficult to catch mistakes inside of this box. So again, check out the link to Expressionist on this page if you're serious about getting into writing your own expressions. All right, that's enough. Thank you so much for sticking with me through that very long process. Now get out there and start making some tapered stroke animations and post your work online. Let us know what you make with this rig. Thanks again, and stay tuned for the next lesson where we're going to add more features to this rig using some more types of expression controllers.